Hi, these are the worked solutions for EDEXCEL's mock set 7. It's the foundation paper 1. We've jam-packed it with extra sort of top tips, hints, keywords, things to look for. So a really useful revision aid. It's going to be great for mocks, for resits, for the actual GCSE. It's really, if you're studying for your GCSE maths, then this is going to be a great paper to do. I would recommend downloading the paper. There's a link in the description. Give it a go and then use this to help you mark and help you with where things may have gone wrong. If you like what we've done here, please hit that like button. Please comment. Great to hear from you. Okay, here we go. There are 100 centimeters to a meter. So we would be timesing through by 100 to get 250. 60% as a decimal is 0.6. If you included that 0, they wouldn't penalise you, but we don't need it. Writing the following in order of size, smallest first. This is our BIDMAS question, so we must do our multiplying first. So we've got 13, and then to solve, we need to get P on its own. We're going to divide through by 4, so P is 11. To work out the median, we're going to need to put these in order first. Again, smallest to largest, but it wouldn't matter if you did it the other way round. And then you just cross off until you get to the middle. So 60 is our median. The range is the biggest, take the smallest. So 20 for the range. Okay, so the length of a rectangle is 2 centimeters greater than the width. So we've got a rectangle. And if the width was, let's say, 4, this would have to be 6 because it must be 2 more. And what I'm doing right now is really the way to approach this problem. You're going to try something and see if it works. And if it doesn't give you what you want, you're going to try something else. So the perimeter of this particular one would be 20. I need one that is 24. So I'm really close. So I might try 7 and 5 next. 7 and 5 gives me 12. Double it gives me 24. That's the rectangle they want. So that's the rectangle we draw. So the coordinates of point P, remember we go along the corridor first, up the stairs. So we've got 3, 2. We've got to do the coordinate -4, -1. So along first, -4, and then -1 would bring us here. And the last question is, on the grid, draw the line with the equation y equals 4. And that's this line here. So you go to your y-axis and cross it at 4. Okay, we've got a list of numbers. We've got to write down a multiple of 8. So that is any number in the 8 times table. 16 is our answer. A factor of 66. So a number that would multiply to make our 66. And that would be 22. 22 times 3 makes 66. And then our prime number in the list is 7. Okay, so Jim has a dog. He buys 6 bags of dog biscuits, and there are 27 biscuits in each bag. So the first thing I would do is work out how many dog biscuits he's got in total. So that's going to be 27 multiplied by 6. Use whatever multiplication method you have. It doesn't have to be this way. 6 sevens are 42. 6 twos are 12. Add the 4, and we've got 162 biscuits in total. He eats 5 biscuits a day. Is there enough for 4 weeks? So we're going to divide 162 by 5. 5s into 1 don't go. 5s into 16, 3 carry 1. 5s into 12 go 2. I've got 2 left over. Add the 0, add the point, and we've got 32.4. There are 7 days in a week. 7 times 4 is 28. We've got enough to last for 32 in a little bit. So the answer is yes, we have enough. Probably the best way to find the one that's not equivalent if you're not confident with the fractions is to just start multiplying them up. I'm going to need to multiply the 2 by 2 to get that numerator of a 4 on this fraction here. And as long as the bottom, when I times it by 2, gives me the 6, I know that that is equivalent. And I can just keep going like that. So if I was to times by 3, that would get me my 6. And 3 3s are 9. That's equivalent. I've got an 8, so timesing by 4 is my 8. And 3 4s are 12. So that is equivalent. The next one is 10. So I'm going to times by 5 to get my 10. And 3 5s are 15. They don't match. That's the one we want to choose. So there are various methods for this particular question. I really like smashed window, so I'm going to do smashed window, but I'm also going to show you the shortcut. If you spot it, it's great to use. So for smashed window, we set up our grid. We put the first fraction along the top and the second fraction down the side, and we just multiply in. So I've got 5 15s. Obviously, I'd have to take a minute to work that out, which would give me 75. And then 4 15s would give me 60. It's a take away question. So I've got 55 over 75. It doesn't say anything about cancelling or simplifying, so I can literally leave my answer, and that is it, done. However, if you're a bit more confident and you can spot that this denominator only needs to be multiplied by 3 to match this denominator, then that's what you would do. That would have given 12 over 15, and we would have got 11 over 15 is our final answer. That is the cancelled version, basically, of this one here. And both would be correct. Both would get you the marks. Happy days. Okay, so Luma makes 32 cakes. We've been given some information, and we're going to use it to complete the two-way table. Now, 32 is really the first number they've given us, and it's going to go here as our grand total. 20 cakes are large. Now, if I wanted to, I could stop right there and work out this missing value. If the total's 32 and I've got 20 large, I must have 12 small. I don't have to stop at this stage. I could have kept going with the information. 4 of the small cakes are not decorated, so 4 small not decorated go there. And again, I could use this to find this one straight away before I worry about the next line, or I could do the next line. It doesn't matter. It's really a personal preference. I'm going to do it. So that has to be 8. These 2 would add to make the total. I've got 9 of the decorated are large. So that's going to give me 9 here. I'm going to find this missing value, which would be 11. And then I'm going to add to get my totals 17 and 15. So we're done. One of the cakes is chosen at random. Write the probability. Now, probability, as soon as you read that, you need to be thinking fractions. 9 times out of 10, you will be creating a fraction. So the probability that the cake is not decorated. So we look at our table. Not decorated has a total of 15. So 15 out of the 32 cakes are not decorated. So you can see where that fraction has come from. In this particular question, they're giving 2 marks for that. They're giving 1 mark for this and 1 mark for that, which is really generous. Okay, so we've been given a graph that shows the information about the cost of a taxi journey in France. How much is the fixed charge? Now, the fixed charge is here. If you think about the distance, we've not actually traveled anywhere yet, and they're already charging us for, well, not pounds, euros, because we're in France. So 4 euros, and that is our fixed charge. Okay, so Jean makes 2 journeys by taxi. One is 6 kilometers more than the other, and we need to work out the difference. Now, it does not matter where in the graph you go. You could go 2 and 8. That is a difference of 6. You could go 4 and 10. That is a difference of 6. So as long as you have that gap, it's going to work out regardless. I'm going to do the 4 kilometers, I think, because I can just see that's giving me a nice straightforward 10. Now, when I go up from the 10, I'm going slap bang in between these two, which you can see would be 19. So 10 is 19. I want the difference between them. So our answer would be 9. Caroline, Felix, and Graham complete a puzzle. We're given some information about how long it took. And we've got to write down the ratio of Caroline's to Felix to Graham's. And we're being told that they are whole numbers. So let's set up their ratios. Well, it's Caroline first, then Felix, then Graham. And then let's go back to the information and start filling it in. It took Felix 3 times as long as Caroline. So if Caroline was 1, 3 times, Felix would be 3. It took Graham a quarter of the time it took Caroline. So we go back to Caroline, and if we quarter a 1, we're not going to have a whole number. So at this stage, you'd be thinking, okay, I need to rethink my numbers a little bit. If Caroline was 4, then I'd be able to quarter that and give Graham 1. I've got to do 3 times Felix, so I'll times that 4 by 3. They are all whole numbers. My second attempt worked a treat. And again, you should expect when you're problem solving to sometimes try an idea or use exactly what they've given you, and it might not just go to plan and you have to do a little rethink. That's maths, that's normal. Okay, so we've got ingredients for making 6 pancakes, but Jenny wants to make 15, and we've got to work out how much of each of the ingredients she needs. So I need to first of all work out how I'm going to take my 6 and get it to be 15, and then I can concentrate on my ingredients. I don't want to overcomplicate this. 6 times something is 15. It's not going in exactly because it's not in the times table. So that might be a more complicated way to do that. I could think that if I had 6 and then I added another 6, that would give me 12. So I'm close. If I added 3, which is only half whatever the 6 is, that would actually get me the 15 that I'm looking for. So that's how I'm going to do this particular question. If I take the plain flour, 100 will give me 6. Another 100 would give me 12. If I half this, it's what I would need for 3. And then I can just add that up, and I've got 250 for my flour. And then I'm going to repeat that process on all of them. And obviously I would be putting that on the dotted line if this was my exam, not leaving it there. That's just to keep it in the screen for you guys. We're going to substitute the information that they've given us into the expression. So we've got 2. Now that's squashed to t. That means times t, and t is 10. Take away 3 times w, which is 6. Now, you do kind of need to think about your BIDMAS because we've got more than one operation. BIDMAS would tell us to do the multiplication first. So 2 times 10 is 20, and 3 times 6 is 18. You then take them away to get 2 as your final answer. For part B, we are grouping together the M's and the P's. That's how we're going to simplify this. So I'm being told that I have 5 M's and I'm to add an M. So I will have a total of 6 M's. I'm then looking at my P's. I have a positive number of 3 P's, and I'm being told to take 2 of them away. So I'm going to be left with 1 P. That's a positive, so I will be putting that plus sign in. You don't need to show the 1, but it doesn't matter if you do. Okay, this is a big question. There's quite a lot for us to do. There is more than one way to do this. I'm going to obviously demo the way that would be natural for me. We're being told that Patrick's going to buy 20 rucksacks, and there is a special offer. They cost £21.40 each, but if you buy 20 or more, you get 15% off. And you've got to work out the cost with the special offer. Now, You can either work out the cost and then take 15% off, or you can take 15% off first and then just multiply it through by 20. And that's the way that I'm going to do it. So I've got £21.40. I'm going to divide that through by 10, which gives me £2.14 for 10%. I want 15%, so I need another 5%. To get that, I'm just going to half, so that would be £1.07. And that way, my 15% is going to come out at £3.21. I'm now going to take that off the cost of the rucksack. So I've got £21.40 and I want to take off £3.21. So that gives me £18.19. I need to now take the cost of one rucksack and times it by 20. Now I'm going to actually double my 18. So I'm in effect multiplying by 2. And now if I times through by 10, that's a nice way to get to the final answer. Okay, so we need to rotate the shaded shape 90 degrees anti-clockwise about the point 10. Now, unfortunately, my software doesn't enable me to demonstrate this as well as I would like. So I'm going to do my best to describe what it is you need to do. And the first thing you need to do is get your tracing paper. Rotating is so hard to do visually, and that's what the tracing paper is for. So you get your tracing paper and you place it over your shape. So first of all, we're going to trace the shape. And the coordinate that we have to rotate in is 10, which is here. We will be turning or rotating our tracing paper anti-clockwise, so in this direction. You will stab this point here with your pencil when you do your rotation, at a top tip. Put a little line, a marker, an arrowhead, something, so that as you're twisting, it will move and you'll be able to sit it directly on the next line, and then you know you've done a perfect 90 degrees. So you just stab, twist your paper, it will show you where you need to draw your new shape. Then you'll just move your tracing paper out of the way and draw it. And that is our answer there. Okay, so we have a key word, regular. Really important that we spot that. That word triggers a formula triangle where you've got 360 at the top, you've got sides and exterior at the bottom. And that is going to help you access and get started on this question. If you've got a regular hexagon, then you've got a 6-sided shape. So to get the exterior, we would do 360 divided by 6. So 6 is into 36, goes 6, and bring that 0 in. Now that's the exterior, which lies on a straight line with the interior. So I know the interior of a hexagon is 120. Because it's regular, they all are. So if we get over here where our X is, I know that from here all the way to here, I've got 120. If I can work out this bit, then I can take it away and I'll understand what my X is. So I'm now into my parallelogram. What I need to know to really help me solve this is that quadrilaterals add up to 360 and the opposite angles of parallelograms are equal. So I know that is also 110. 360, take off the 220, the total of these two gives me 140. That 140 needs to be shared into the two angles. So I now know this is 70 degrees. 120, take off the 70, gives you 50 degrees as your final answer. Okay, simultaneous equations. In order to work these out, now, if you are taught by me, you will know that I say always get the first term the same. So that's the way that I will be doing it. You can match your y's and work it through that way as well. I'm going to multiply by 4 the second equation, and that's going to give me 4x plus 2y equals 3 for the first, because I've not done anything to that, and 4x minus 4y equals 24 for the second. And now I'm going to take away the x's, take away the y's, and take away the numbers. Now I can see that 2 negatives here is going to make a positive, and I can also see here I'm going to go into a negative number. So let's do this. 4x take 4x is gone. It's eliminated. That's what we want. We want to get rid of the x's so we can concentrate on the y's. I've got 2 y's, and I'm going to add 4 to get 6y. And then 3 take away 24 will take me to negative 21. I want to know what y equals, so I'm going to need to get it on its own. So I'm going to divide through by 6. Now, 21 isn't in the 6 times table. I could go to bus shelter and do it that way, or I could stay in my fractions. How many 6's go into 21? 3. 6 3s are 18, so I've got 3 left over. If I cancel the 3 6, it will get me to a half. Remember, this was negative 21, so my answer will be negative. And then I'd change it to a decimal because I don't really want to work in fractions. Equally, you could have just gone straight into bus shelter with your 21 and divided that through by 6. Now I know the y value, I can use it to find the x value. Always use your originals, just choose one. I'm actually going to choose the top one because there's no negatives in it, and I already got a negative result, and if I worry about my negatives, it might help to avoid more. So I'm going to do 4x plus 2y equals 3. Now, 2y, 2 times minus 3.5 is going to give me minus 7. So what I've actually got is 4x minus 7 equaling 3. And then I can go on and solve in the normal way. Now, my method with my class is to hop. So we're going to pick up the minus 7, add 7, and we've got 4x equals 10. Divide through by the 4. And again, you can do your bus shelter, you can do your fractions, or you may just know this one. So 4's into 10 go 2, remainder 2, and 2/4 is equivalent to a half. So we've got 2.5 for our x value. Okay, so we've got Tim, Jason, and Peter. They're going to share £60. So invisible column. These add to give me 10. The question has 60. To get from 10 to 60, I times by 6. So I'm going to do the same on this side. However, they only want me to work out what Jason gets. So it's going to be 2 times 6, which is 12. Okay, so Dave is 3 years older than Colin, and Ruth is 3 times as old as Dave. Colin is my problem. If I knew his age, I'd know Dave's, and then I'd know Ruth's. Because I don't know Colin's number, I'm going to just assign him a letter. And that's what we do in maths. If I knew Colin's age, I'd know everybody's. I don't know Colin, so I'm going to call him X. He has a number I don't know. Dave is 4 years older, so he's Colin's age plus 4 more years. And Ruth is 3 times as old as Dave. So we're going to multiply Dave's expression by 3, which would give us 3x plus 12. The total of the 3 ages is 56. These are the 3 ages in algebra. When I add them, I get the total of their 3 ages in algebra. I can set that to equal the 56 they've given me. So what I've got here basically is the algebra version of their age and the numerical version of their age, and they have to be the same thing, hence the reason that I can create my equation. And I'm just going to solve this. So I'm going to take off the 16, to leave me 5x on this side equaling 40. Divide through by the 5 and x is equal to 8. Now, top tip, always check the last line because you could easily stop at this stage. You feel like you've done a lot and it feels like we've worked out x, so we've kind of finished, but we haven't. We want Ruth's age. Ruth in algebra is 3x plus 12. Obviously, we now know the x is 8. So it's 3 times 8 plus 12, which is 24. Add on your 12, and she is 36. Okay, the volume of a solid cube is 125 centimeters cubed, and we've got to work out the surface area. Now, the first thing that I would do with this is draw myself a cube. It may help, it may not, but actually, if you've got some visuals to look at, it can often make a difference. Now, I know that the volume is equal to 125, so I need to think about how we would have worked that out. We would have multiplied the cross section, it tells you that on the formula sheet, by the length. So I would have done this edge multiplied by this edge multiplied by this edge because it's a cuboid. So something times by something times by something is going to give me that 125. And it needs to be the same number because it is a cube. So you would either work it through by just trying an error. So like 2 times 2 times 2, not big enough. 3 times 3 times 3. Or you may just sort of spot that it's got that 5 on the end and think, I'll try the 5s first. It is 5. So the edges of my cube are 5 centimeters. I've got to work out the total surface area. So one face would be 5 times 5, which is 25. You've then got to think about how many faces there are. There are 6. The dice can help with that one because they're numbered, aren't they? So they're numbered 1 to 6. There must be six faces. So you're going to times through by 6 and get an answer of 150 centimeters squared. Okay, our key word here is estimate. If we miss that, we're likely to try and do this piece of work as accurately as we can. And that would get us no marks whatsoever, sadly. So estimating means we need to round these numbers. So we're going to round this to 6 kilometers and to 20 minutes. If he's walking 6 kilometers in 1 hour, so that's what we're being told, and we need to give the distance in meters, then we're going to need to change this. Timesing through by 1,000 will give us our meters. So it's 6,000 meters in an hour. But I'm going to represent my hour now in minutes as 60 minutes because, again, they want us to work out what they're going to do in 20 minutes. I can cancel this down a little bit just to make the math a bit easier. And then 6's into 600 is 100. So because I've divided completely through by 60, I've now worked out what I can do in 1 minute. I want to know what we're going to get in 20 minutes. So I'm going to do 100 times 20 to get my final answer. Now, it would have been just as easy at this stage to have used the 19 that I'd been given because I'm timesing by 100. And if you did that and got 1900 as your answer, that would be fine. They do allow a range. So 1800 to 2000 was on the mark scheme for this question. Now, the last part isn't always asked, but it does say, is your answer an underestimate or an overestimate? Now, when you read that, that could be the trigger that you may have gone wrong here if you hadn't rounded. Okay, I've marked many, many papers and I have read a response more than once that says it's neither because I've calculated it properly. And they didn't kind of get the hint from this. So I'm kind of emphasizing it for that reason. For us, it is over because we have rounded up. Okay, so this type of question, which is wordy, and also you've got piece of algebra, like a letter in here, can be incredibly confusing and off-putting for many students. So we're going to do this by just breaking it down. We're going to act like we've read it, act like we don't necessarily really fully understand what they want from us, and just do it step by step to see if that helps us lead into the next part and lead into the next part. So it says a third of the profit is shared equally between the two directors. So I need a third of the profit, which is a third of our 18,000. Now, all we have to do is divide by the bottom. So 18,000 divided by 3. 3's into 18 go 6. And then you can bring up all those zeros. So they get 6,000 between them. Take that off of the total and you get what the employees have to share. So we now need to share this between the 24 employees. All right, the rest of the profit is shared equally. So we've got our 12,000 and we're going to divide it through by 24. But when we look at that, I don't know about you, but I certainly don't want to start writing out my 24 times table. What I can do is I can just divide the whole thing by 2, both sides, and get an equivalent question to work on. And let me show you why we can do this. If I had 8 over 10, I could divide that through by 2, and then I would have 4 over 5. This is 8 divided by 10. This is 4 divided by 5. They're equivalent, and that's what's happening by doing this here. We're just writing equivalent. So I hope that helped and didn't cause any additional confusion. But they're both even. I could get on straight away with this if I wanted to, or I could divide by 2 again if I'm not happy with my 12 times table. I am happy, so I'm going to just stick with it here. So 12s into 6 don't go, carry the 6, and then 12s into 60 just go 5. Bring up the zeros, and I've got 500. So I now know that the employees get £500 each. The amount each director gets is n times the amount each employee. Now we know that the employees get 500. Each director is what we haven't done. Our 6,000 that we found right at the beginning was for both of them. So each director would get 3,000. So what we've got to finish off is 3,000 for one director is equal to a number we don't know multiplied by 500. So 500 times something. And you can do this almost on your fingers if you wanted to, until you got to your 3,000. The answer is 6, and that's what they were looking for. Okay, we've got a probability tree diagram that has already been started for us. So in the first bag, the probability of getting blue is 5/8. So the probability of getting red is 3/8. These have to add to 1. So that's one way of making sure that you've got that right. You've also got your information here that you've got 3 red discs. We're then going to do our second bag in exactly the same way. We've got a 7/11 for blue. So that means that we've got 4/11 for red. And then we just repeat it on the other one. Work out the probability. Kavita takes 2 red discs. Well, let's look at that pathway. Red from the first bag, red from the second is that pathway in my diagram, which gives me these fractions. So we're going to take those fractions and we multiply them, and that's the knowledge they're testing. You do not need to cancel. You can just give your probability in the answers that are created. So Alice is asked to draw a graph, and there it is. And we have to write down one thing that is wrong with her graph. And it's the fact that she's used straight edges, and she should have drawn through those points using a smooth curve. And that's what we would write down. Okay, our last question, and the first part is an indices question. So they're testing, do we know our indice rules? And in particular, what we do with a times question. So when you have a times question, you are adding the powers. Now, before we worry about the powers, we've got some number work to do first. 3 times 5 is 15. And then our x's, we've got x squared times by x cubed. So we just add those powers, and we've got x to the 5. And then we've got y cubed times y. Now we are multiplying in an extra y. It kind of has an invisible power 1. And when you add those, you get y to the 4. Now, there are various methods for expanding and simplifying. I'm going to do crab's claw, but there is a really nice grids method, which some people may do, and that would look like this. In fact, now I've drawn it out, I might as well do it like that. So 3 times 2 is 6, k times k is k squared. We're multiplying in like a times table grid. So 3k times 1 is 3k. Then I've got minus 8k and minus 4. Be really careful here. What I see is the most common mistake is people saying minus 4, add 1, and then writing minus 3. Remember, you are multiplying in, not adding at that stage. This middle section, I call it the nugget method because it looks like a little nugget. That has to be grouped together because they are just single k's, so they can go together to make their own group. My final answer then is 6k squared. I've got 8k, sorry, I've got minus 8k, and I'm going to add 3. If I'm at minus 8 and I add 3, I'll end up at minus 5. And then I've got that minus 4 on the end. And we're done, which is fabulous. Okay, so watch out for papers 2 and paper 3 so that you can complete the set. And yeah, I hope that has been helpful in your preparations.